Have you ever stopped to think about what everything is made of? Your chair, your lunch, you? It's all made of tiny, tiny things called atoms. For a very long time, people thought atoms were the smallest things possible. They thought they were like super tiny, solid little marbles. Imagine a universe full of these unbreakable building blocks, clicking together to make everything we see. But it turns out there's a secret hidden inside these atoms. This secret is the electron. Electrons are incredibly small, way, way smaller than the atom itself, buzzing around inside every single atom in the universe. Think about it. The air you breathe, the water you drink, the phone you might be holding right now. They are the source of electricity. They make light bulbs glow. They make your television show you pictures. Without electrons, our world would be a very different and much darker place. They are the energetic heart of the atom. Understanding them unlocked a whole new level of science and technology. How did we find something so small you can't see with a regular microscope? It took a brilliant scientist with a curious mind. He wasn't looking for a new particle. He was just playing with electricity in a glass tube. But what he saw would change the course of history forever. A mysterious glow, a beam of light with a mind of its own. It was a clue that atoms were not solid marbles. They had parts. One of those parts was about to make itself known. Our story starts in a laboratory in the late 1890s. A scientist named J.J. Thomson was doing some very cool experiments. He used a special piece of equipment called a cathode ray tube. It's a sealed glass tube. All the air was pumped out. It's a vacuum. Inside the tube were two metal plates, one at each end. Thomson hooked the plates to a powerful electric source. Something amazing happened. A mysterious beam shot from the negative plate, the cathode. It aimed at the positive plate, the anode. This beam was the cathode ray. No one knew what this glowing beam was made of. Was it a type of light? Was it some kind of invisible fluid? Thomson was determined to find out. He was a professional question asker. He decided to test the beam. His big idea: see if he could push the beam around with other forces. First, he brought a magnet near the glass tube. And guess what? The glowing beam bent. It moved. This was a huge clue. Light from a flashlight doesn't bend near a magnet. So the beam was something else. Something with electric charge. Next, Thomson used electricity to move the beam. He placed two more metal plates inside the tube, one above the beam, one below it. He charged one plate positively, and the other negatively. Just as he suspected, the cathode ray bent again. It curved away from the negative plate, and toward the positive plate. Imagine being J.J. Thomson in that moment. You're standing in your quiet lab, surrounded by glass tubes, wires. For weeks you've been watching this strange green glow, trying to understand what it is. You've run the tests over and over. You've checked your math again and again. And then, it hits you. The numbers don't lie. The particles in that beam are smaller than an atom. This isn't just a discovery, it's a scientific earthquake. For 2,000 years, the atom was thought to be the fundamental, indivisible unit of matter. And you, J.J. Thomson, have just proven that idea wrong. You have found something smaller. This was his eureka moment. Sudden, brilliant understanding. Not a loud explosion, but a quiet revolution inside his mind. A huge jolt of excitement, pure joy and wonder. He realized he was the first person in history to understand this truth. The atom was not a solid ball. It had parts. Tiny, negatively charged parts. Corpuscles. They were in every single type of atom. Breathtaking. This would change the world. Think of the courage to announce it. He was going against centuries of belief, telling every scientist their basic assumption was incomplete. He might have been nervous, but the evidence was undeniable. The glow in that tube was proof. He'd seen the ghost in the machine, the secret ingredient inside the atom. He had to share what he found. The excitement drove him to tell the world. In 1897, Thomson announced his discovery. He proposed a whole new model of the atom: plum pudding, blueberry muffin. The discovery of the electron didn't just add a fact to science, it completely changed the game. Before Thomson, the atom was seen as the end of the line. It was the smallest possible thing. But now, scientists had to think differently. The atom had a complex inner world. It had smaller pieces inside it. This opened up a brand new field of science, subatomic physics. Scientists everywhere started racing to figure out what else was inside the atom. Thomson's plum pudding model was just the beginning. It sparked a creative explosion in the scientific community, leading to new models and new questions. This new understanding of the atom was like finding a secret blueprint for the universe. It helped explain things that had been mysteries for a long time. For example, it helped us understand static electricity. Why does a balloon stick to the wall after you rub it on your hair? It's because you're rubbing electrons from your hair onto the balloon. It also helped explain chemistry. Chemical reactions are all about atoms sharing or swapping their electrons. The discovery of the electron gave chemists the key to understanding why certain elements combine and others don't. Science was no longer just about observing the world, it was about understanding its fundamental rules. The idea of a particle smaller than an atom also pushed technology forward. To study these new particles, scientists had to invent new tools. They built bigger and better atom smashers or particle accelerators. These machines use powerful electric fields and magnetic fields, the same forces Thomson used, to speed up particles and crash them into each other. The quest to understand the electron and its siblings led to an incredible era of invention and engineering, all aimed at peering deeper into the heart of matter. And so, Thomson's simple plum pudding model didn't last long, but that's the great thing about science. It's always moving forward. A few years later, a scientist named Ernest Rutherford did another famous experiment. So, a tiny particle discovered in a glass tube over a century ago. What does that have to do with you today? Everything. The science of controlling electrons is called electronics, and electronics are everywhere. Look at the smartphone in your hand or the computer on your desk. They work because we can control the flow of billions of electrons through tiny circuits called microchips. Every time you send a text, watch a video, or play a game, you are using technology that is a direct descendant of J.J. Thomson's discovery. We have learned to tell electrons where to go and what to do, and they power our entire digital world. It's not just in our gadgets. Have you ever seen an X-ray of a broken bone? An X-ray machine works by shooting a high-energy beam of electrons at a metal target, which then releases X-rays. More advanced machines, like a CT scanner or an MRI machine, also rely on the principles of subatomic physics that began with the electron. These amazing tools allow doctors to see inside the human body without ever making a cut. Think about how we get our light and energy. The light from an LED bulb comes from electrons jumping around inside a semiconductor material. The electricity that flows through the wires in your home is nothing more than a river of moving electrons. Even solar panels work by using sunlight to knock electrons loose, creating an electric current. From the biggest power plants to the smallest solar-powered calculator, our ability to generate and use energy is fundamentally tied to our knowledge of the electron. We have truly harnessed the power that J.J. Thomson first glimpsed as a faint glow in a tube. From a mysterious beam in a lab to the foundation of our modern society, the electron has had an incredible journey. It revealed that the atom was not an unbreakable sphere, but a complex and wonderful system. This discovery didn't just change science. It unleashed a wave of technological innovation that continues to shape our lives every single day. The next time you turn on a light, use your computer or see a medical scan, take a moment to consider the humble electron.